All right, hi everybody. This is Mrs. Houts, and we are going to move on in our adventure of naming and writing ionic compounds. This is the last bit of doing this with ionic, and we're just introducing a new twist. These are called type 2 binary ionic compounds. Oh, sorry. Okay, so here's a few definitions. Type 1 binary ionic compounds have a metal that only have one charge. So that's actually the kind that you've been doing this whole past week. Things like sodium chloride, potassium oxide, things like that. Type 2, this is the new one for today, binary ionic compounds have a metal. They still have a metal and a nonmetal, but the metal has more than one possibility for its charge. So in other words, it's not always the same charge. Okay, these are called type 2 metals, and they're also called multivalent metals, and these are the transition metals. Okay, so this is going to answer the big mystery, which I'm sure is keeping you up at night, about why the charges aren't written on that section of your periodic table for the transition metals. Okay? So why don't we just go for it here? First, let's look at the periodic table and go over the type 1 metals. So I have red boxes around different families. So the alkali metals, you know there's a +1 on the top of that column. So every single time one of the alkali metals becomes an ion, it will have a +1 charge. Okay, so that's why they're always +1. It's not why. Type 2, I'm sorry, +2 charge is what the alkaline earth metals will have when they become ions. So for example, calcium will always have a +2 charge. And then aluminum over here will always have a +3 charge. So aluminum is also considered a type 1 metal. So that's what I mean when we say they'll always have the same charge. You know, it's not going to be variable. The transition metals, on the other hand, can have more than one charge. Okay, so I put a big box here around the transition metal part of the periodic table. Most of it. I don't have the intertransition metals. And then the ones we're mostly going to be using are in this green box. So the first row of the transition metal section, these elements we'll use a lot, and then tin and lead over here are also very common transition metals, and we'll use those a lot also. I don't have zinc in the green box. It's a transition metal for sure, but it always has a +2 charge. So it isn't one of these other ones that can have variable charges. So what I mean is, when I say that, if we look at copper, for example, copper can have a +1 charge or a +2 charge. And so it just depends on what it's bonded with. That helps to determine the charge on that copper. Iron can have a +2 charge or a +3 charge. So that's what we mean when we say they're multivalent, or that they can have more than one charge. Okay? And these are actually listed on the back of your periodic table in table F. Okay? So you can take a look at that when you get a chance. Let's practice. Oh, wait. Sorry, if you're in my class, I posted this naming flowchart. So let's just look on this thing and see where we are. All right, we have a compound. We've been coming down this fork where we have a metal and a non-metal, and so this is the ionic category. So all last week you were doing the type 1 binary ionic, and now we've moved over down this fork to where our metal is multivalent. Okay, and the rules for naming this kind of ionic compound is almost exactly the same. There's one little twist. Okay, so I made this box bigger, and here are the rules. You still say the name of the metal, but now we have to use a Roman numeral to indicate the charge of the metal. Since the metals can have different charges, we have to tell the world what charge it is in that case, and we do that using a Roman numeral. Okay? And then we'll name the nonmetal or the polyatomic ion. Okay, so the rest of that is just the same as what you've been doing. All right, so I just sort of wrote these out here again to name it. First, you recognize that you have a transition metal, and whenever you see a transition metal, you realize, hopefully, the bells in your head go off that you're going to have a Roman numeral in the name. Okay, so you just write out the name of the metal, And then I'm going to use the anion to figure out the charge of the metal. So I'm going to use the negative part of the compound to figure out the charge on the metal. All right, and then again, you use Roman numerals to show the charge. All right, so let's look at an example. Okay, here is CuCl versus CuCl2. If we look at CuCl, first of all, so we need to figure out the name. So when I say I look at the anion, I look at Cl, it has a -1 charge, and I have one of them. So the negative side of this adds up to -1, which means that the positive side has to add up to +1 because ionic compounds have to be neutral. And then, since I only have one copper, the charge on that copper has to be a +1. All right, and so that +1 gets put down here in these parentheses, and the name of this thing becomes copper, Roman numeral 1, chloride. Or usually we just say copper 1 chloride. Okay, on the other hand, CuCl2 over here, we need to name this one. All right, and I look at chloride again. It's got a -1 charge, and I have two of them. So overall, the anion side is a -2. So the positive part has to be a +2. And I only have one copper, so that copper has to have a +2 charge. And then I would indicate that with this Roman numeral 2. So the name of this one would be copper 2 chloride. Okay, so you can see that these things look a lot alike, but if you just named it copper chloride, the whole world's not going to know which copper you've got, and that is not good if you are trying to tell the world what kind of copper chloride you've got. All right, so let's do a few practice problems. I'm going to switch, to my paper because I prefer to write. All right, so I will be back. All right, so we're going to practice naming these. These all contain transition metals, so they're all type 2. I wrote out the rules up here. So the first thing we're going to do is write the name of the metal. Then we're going to use the anion to figure out the charge on the metal, and we're going to put that charge in parentheses with a Roman numeral. Okay, so the first thing we're going to do is figure out the name of that metal. All right, Pb is right here. So Pb is lead. All right, so I'm going to call this lead something, because I know I need a Roman numeral, and Cl is chloride, and it has a -1 charge, and I have two of them. So in this case, this side has to add up to -2, or it does add up to -2, which means that the positive side has to be a +2, and since I only have one lead, that has got to be lead +2. So this is going to be lead, Roman numeral 2, chloride. So that's the name of that one. All right, let's look at this one. PbCl4. Well, it's still lead, so I will go lead. And I know I need a Roman numeral because lead's a transition metal. And Cl is chloride, so lead something chloride. All right, so I'm going to make my table again because that helps me keep this all straight. Chloride has a -1, and I have 4 of them. So that adds up to a -4, which means that the positive side has to be a +4, and I only have one lead over there, so that is going to be the +4 version of the lead. So I show that by putting Roman numeral 4 into parentheses. All right, let's do this one. MnO. All right, Mn is right here in the first row of the transition metals. So I know now that I need to have a Roman numeral in the name. That's manganese. So this is going to be manganese something, some Roman numeral, oxide. Oxygen, when it becomes an ion, is called oxide. All right? So I'm going to make my table. Oxygen has a -2 charge when it's an ion. That is right here. Here's oxygen. There's its charge. And I only have one oxygen, so this whole anion side adds up to a -2. the cation side has to be a +2. And I've only got one manganese, so it's going to have a +2 charge. So that charge gets put into those parentheses as a Roman numeral. So this name is manganese 2 oxide. All right, let's do one more. All right, Mn2O3. Well, this is manganese again. Manganese, some Roman numeral, I haven't figured out which one yet, oxide. All right, so let's look at the anion to figure out the charge on the metal. So I'm going to make my table. Whoops. Mn2O3. I have 3 oxygens, and they each have a -2 charge. That adds up to a -6. My cation side has to add up to a +6, so that it will equal 0. And I have 2 manganeses. 2 mangani? What's the plural of manganese? All right, so they have to each be a +3. All right, because 3 plus 3 is 6. And now I have my negative and my positive that will cancel. And you put the charge on the manganese in your parentheses as a Roman numeral. So this is called manganese 3 oxide. All right, so I'll just throw in a little mini comment here because I should have said this earlier, but 1, if you have a +1, then the Roman numeral would be Roman numeral 1. If you have a charge of +2, I guess I'm not sure if you guys know your Roman numerals is all. Roman numeral 2, a charge of +3, Roman numeral 3, a charge of +4, Roman numeral 4, charge of +5. 5 is a V, and 6 is a VI. Okay? All right, let's go back to where we were then. Okay, so these are the ones we just did on the paper, and we got these answers. Lead 2 chloride, lead 4 chloride, manganese 2 oxide, manganese 3 oxide. And so I hope again that you can tell that PbCl2 is not the same as PbCl4 because the leads have different charges. So again, you can't just say lead chloride because all your chemist friends will be confused. Okay? As will your teacher. All right, so this is a very good place to pause. Why don't you pause the video and go to that Google Doc that's attached to your assignment and see if you can't do the first set of problems, which is naming what we just did. And then come back and we'll finish this up. All right, we're back. Okay, so we are going to now carry on and go in the other direction. Okay, so what you just did was taking the formula and figuring out the name. And now we're going to take the name and figure out the formula. So again, you did this with type 1 compounds, and it's just the same. We just have this twist of the figuring out the charge of the metal. So we can do it. All right, so here's what you do is first you name, first you have to realize that you have a transition metal in there. And you know that because there's a Roman numeral in the name. Okay, and then you just change your, the ending should say IDE. Okay, sorry. All right, so let's just try this iron 3 chloride. All right, so step 1 is you would write out the symbol and the charge for the element. So this iron Roman numeral 3, by definition, means that the iron has a +3 charge. So you would write that down. Chloride is a -1. Okay, now you have to actually pause and think about this for a second because you need to figure out how many of each ion you're going to need so that this ionic compound adds up to 0 or that it's neutral. So in this case, I need a total of 3 chloride ions. That will give me a -3 charge, which will cancel out the +3 on the iron. Okay, so that is why our formula then would have 1 iron and 3 chlorides, FeCl3. All right, so let's do another few more of these. And again, I'm going to switch back over to my paper. Okay, so we're just going to practice a little bit writing formulas for ionic compounds that contain transition metals. Okay, so I wrote down the steps here, write down the symbols and charges of the elements, and then figure out how many you need of each to end up with a neutral ionic compound. So that sentence right there is crucial. That's the thing to remember. And then you can write the formula. Okay, so let's do number 1 here. Iron 2 nitrate. Iron with a 2, Roman numeral 2, the symbol for iron is Fe. It's right there. And that Roman numeral 2 tells me that that iron has a +2 charge. So that's my metal. Nitrate does not end in IDE, so that's your clue that it's a polyatomic ion. And you should look on the back of your periodic table. So let's find nitrate back here. All right, scanning, 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 scanning. Here it is, nitrate, and its symbol is NO3, and it has a -1 charge. So iron is a +2, nitrate is a -1. All right, now we're on step 2 up here, where we have to think about it, figure out how many we need of each, so that this compound ends up neutral. All right, so sorry, I thought my dog was about to come in here. All right, so I have one of those, and I need to have another one of these nitrates so that this side adds up to a -2, because this side is a +2. Okay, so now I can write my formula with 1 iron and 2 nitrates. So you would write iron, and then remember, whenever you have more than one copy of a polyatomic ion, you need to put that into parentheses, and you put the number that you have outside the parentheses. Okay, so Fe NO3 with a 2 on the outside. All right, let's do this one. Copper 1 chloride. So copper is Cu, and it's right here. All right, and the Roman numeral 1 tells me that it has a +1 charge. Chloride is my anion, has a -1 charge. So this one's not too bad. +1, -1, they'll cancel. So my formula, I just need one of each of those. All right, let's do number 3. Lead 4 hydroxide. All right, lead, again, is right here, Pb, and that Roman numeral 4 means that it has a charge of +4. Hydroxide is a polyatomic ion, so you got to find it on the back. Let's scan down here. Scanning, scanning, beep, 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 beep. So here's hydroxide, and its formula is OH, and it has a -1 charge. OH -1. Okay, so then you think for a second here, well, I guess I need a few more of these -1 things to cancel that out. And you would be correct. You need to have a total, of 4 hydroxides to cancel out one of those lead +4. So that adds up to -4. 1, 2, 3, 4. That side's a +4. And now we can write our formula with 1 lead and 1, 2, 3, 4 hydroxides, which again, we would need to put into parentheses whenever you have more than one copy of a polyatomic ion. Okay, so let's do the last one here. Tin, Roman numeral 2 oxide. So here's tin, right above lead. Its symbol is SN. SN, and the 2 tells me that its charge is a +2. Oxide is an ion of oxygen, and it has a -2 charge right there. Oxygen -2. So I got one of those, and it'll add up to 0. So my formula would just be SNO. Okay? Okay, so these are the ones that we just did, and here are the answers that we just got. Okay, so that is all I've got. So now you can go back to that Google Doc and finish those problems that you haven't done yet about writing formulas. All right, and please let your teacher know if you need any help.